Hello everybody, welcome back. It has been a while. I intended to upload one uh, last week and I actually did upload it, but it turned out I messed up my microphone settings a little bit. So there was no sound whenever I had my desk cam on. So that's not good. So I'll redo this one. It's gonna be a pretty straightforward one. This time I want to do rotary encoders. So generally, we all work now with GPIO pins, but always as an output. And right now, I want to use them as an input, because that's also a very interesting use case for the embassy asynchronous programming. Because then we need to deal with something happening at some moment, and then dealing with it in a gracious way is very interesting. So. Other thing I want to change from now on is that I want to create a separate repository for each episode, because I'm working on a few at the same time often, and yeah, it drives me nuts to do everything at once and then forgetting which one it was, and then schedule the episode, and then pushing and then forgetting to push, all that kind of stuff. So I'll just do a repository per episode. So we will start off with the first no standard one, where we just blink the LEDs, and start from there, and then add the rotary encoder and see where we end up. So let's yeah, we can take a quick look at the code, but yeah, if you didn't watch that one, it was basically the green LED blinking and the red LED blinking in some different frequency, and they just blink, and the point was there to see that you have those different tasks who do some cooperative multi-threading and how that works. So let's deploy that to our our device. Sorry. So let's run ESP flash, right? That's what we always do. Should be there. Oh, my camera's off. Wait. There it is. So it's building, it's uploading, and it just crashes. I don't know what happened. The code is completely unchanged as far as I can tell, but it doesn't work. I think the only thing that really changed is that I actually updated the Rust nightly since I put out that episode, so that might be a thing. However, we have to bear in mind that we are using a whole lot of nightly things pointing to yeah, just commits. So yeah, your mileage may vary. So I spent some time trying to figure out what was wrong there. And the important part was that this one has a released version now. Let's look that one up. Let's create a browser, go to docs, and see if we can find Embassy Executor 031. Oh, why the hell not? Let's try if that does anything. So version 031, and remove the revision. So I don't think it will work out of the box. Let's see, because there were some pretty major changes in Embassy, so we might need to deal with some stuff. Yeah. Let me check the difference with the one I figured out. It's a matter of adding some features. Is that something you can see here easily? Which features exists? Maybe on creates, I know. Not really. Let me do a diff with the one I fixed before. Backup, I think. Cargo, Tomo. Yeah, you don't need all of that. Yeah, we need to add architecture. And I think also the executor thread. Okay, so that I think that changed. I think they moved around some stuff. So this needs to have the architecture of this chip. And I already forgot. Let's see what this does. It's building. I think there was one more thing. Let me check. Executor thread was the one that we need nowadays. It's yeah, I would love to say that I exactly know what, why, when, but it is what it is. So let's add this one, and that should clean that up. Yeah, now it seems to compile at least. Let's push it to the device. Not really. Let's see, executor. Let's recheck if there was something else. Maybe the embassy time needs to be updated, I'm not sure. So the error message is kind of weird in the sense that it complains that it's somehow not using the embassy executor, but that doesn't seem like something that would change between versions. Anyway, let's try again. That is super weird. I'm gonna remove the cargo log file. Maybe it got into a funky state. I implemented this before and then I rolled back, so maybe that did a thing. Now it works. So yeah, those things are funky. So maybe maybe that's just the thing that you need to re-evaluate the logs, or maybe just do a cargo clean. I don't know, but it's looping, and there is the psychedelic blinking. So now we are basically where we thought we were when we started. So to get started on rotary encoders, a rotary encoder is generally a knob. I'll unplug it for a moment so it's a bit less annoying to look at. And I wired it up with 4 wires. There are 5, but I'll talk about in detail later. And there's a knob, and you can rotate it. And you can rotate it forever. It's not like a potentiometer that will rotate only so far. They have to rotate back. This is just a knob, and there's a little bit of a spring in there, so it feels like there is some texture to the rotating. It's basically a mouse wheel. Those things are everywhere. Super cheap. So, but they can be nice, nice user interfaces. So, this thing, a rotary encoder. I'll quickly explain the encoder. I'll quickly loop one up. Let's see that side. And this is pretty much the exact one I have, I think. And what it basically is 2 buttons. And 2 buttons that are somewhere in the rotation, and they overlap a little bit. So what happens if you rotate it one way, say button A gets pressed, and then button B gets pressed, and then button A gets released, and then button B gets released. And based on that overlap and detecting the changes, you can detect which way the wheel turned. And that's basically what we want, right? We want to notice when it moved and in which direction. So what we need to do, we have a ground. So in terms of wiring, we have a ground, we have a voltage. I don't think it matters how much. There's the switch, so that's the extra part. You can also press down on it and then it clicks. I'm not using that at all, but it's there. And there are the 2 buttons. So when it energizes the button, so to speak, it will pull it to ground. So that means that when it's not pulled to ground, it needs to have a little bit of current upwards. So so that when it's not connected, it will actually be up and not anywhere. So for that, there are so-called pull-up resistors that are inside the boards, the developer board as well. That you can say, like, I want to have a little bit of a resistance upwards, so it will be high if nothing is pulling it low. So the wiring, pretty straightforward. I just yeah, the voltage and the ground are obvious. They're just linked, and I connected those, the 2 buttons, to pin 4 and pin 5. So let's have a look. So I'm using those pins because they're also wired to the internal LED, so that's what you saw blinking, right? We were just putting those pins high and low, and that is the blinking LED. So you can actually see what's happening. But that means because I connected to 4 and 5, that is the same pin as the green blink. So I'm gonna remove that for the time being. So I removed here as well. So now we only have the red blinking. And we have here pin 4. We make it into a, we used to make it into a output, but we want to have an input. So into input, something like that. Yeah, pull up input, that's exactly right. So that means that we have, that it will be high unless something is pulling it low. And we also do that for pin 5. Pin 5, pin 5. I think we can always do this more generically, but it does not matter for now. And let's create a new function that will model our rotary. So again, it will be an async function Let's do just rotary. We need both pins. Not sure if they need to be mutable. I'll just call it pin A. We'll see if it needs to be mutable. It will tell us. GPO4 with is that pull up input? I think like input pull up. Right, so that's one pin, and then another pin. Two pins in here. Oh, and we of course need to add the annotation embassy executor task. Alrighty. So this will get called, right? And if well, we need to add it here, of course. Spawner spawn. That was called rotary with pin 4 and pin 5. Now we just give ownership. We unwrap it. Semicolon. Pin 5. Probably mess that up. 4, 5. This one is correct. So probably this one needs to be pin 5. So all good. Not all good. Add the imports. Oh. Import GPO5. Now all is good. So now what? So we have some kind of loop here, right? This thing is gonna loop, and from time to time we need to await something to release the control. So those pins, they have a function we can call, and that is called wait for an edge. So we can wait for a falling edge, for example. That is when it goes from voltage, so +5 or 3, I'm not sure, to 0. That's a falling edge, and if it goes the other way, it's a rising edge. But in this case, we're interested in any edge. If it moves, we want to know. So that will mean that it will await, so it will remove the control until that happens. The moment that happens, this this loop will reactivate. However, we now are waiting for pin A to move, but pin B might move first. So we want to listen to both. And for that we need an extra feature of Embassy, and that's called Embassy Futures. Let's edit. And Embassy Futures has a thing that's called select. Or does it? Select. There it is. Just needed a moment. And select. This is not super clear. Select is a function call, and we can add in two sources of awaiting. So two things that might happen, and the select will await until one of them happens and then tell us which one happened. There are also other variants. There's a select 3 and there's a select 4 where you can listen to more things. I'm not sure how far they go. I guess until 4. But in any case, we only need 2. So we select pin A and pin B. And that is not a function, it's a macro, I think. Right? Or am I? Select. Yeah, import this thing. I think I messed up the import before. Yeah. I will just remove this one. This is messed up. Let's try to get the right one this time. Import select. Select. Yeah, okay. So this thing returns something when either of those happens. And then we can await it, I think. No. We forgot all the wait for any edge. Wait for any edge. And then we need to semicolon here. Now we're getting somewhere. It says it needs to be mutable. Fair enough. Then I was wrong. I doubted if it needed to be mutable. And this needs to be awaited. And I think no. So and I guess now we got a result, right? So let result equals that, and if I activate the types, it says either, and in this case it's not that interesting because they don't actually return anything. We just know that apparently something happened, so we can kind of ignore this, and we just know that something moved. So now decoding the whole the edges and the level. So there's always, when one moves, then one has an edge, the other is either high or low. That tells you the direction. But it's actually quite finicky to work with. So I found a small library that helps with this. And that is called rotary encoder hell, I think. Well, you know, it's the right one. And that helps with that encoding. So let's, at the beginning of the method, create an instance of that thing, that library. Let rotary equals rotary encoder. My Rust analyzer seems to be acting up, but let's see if we can get it here. Did it do an import again, maybe? It added this one, that should be all right. Rotary encoder. What's wrong with this thing? Oh, it just crashed, I think. Alright, let's kill VS Code and create a new one. Anyway. Still building. Let's give it a moment. Okay, let's see if we can find the thing now. Let rotary is rotary. Hello. It is not expanding at all. Oh yeah, it's getting there. Okay, rotary encode. Yeah, now it's doing something. Okay, yeah, that one. New, I suppose. Yes, and it needs 2 pins. Well, that's a nice coincidence. Even the name is right. Okay, so now we gave those pins to the rotary encoder, and what we can do then is to, whenever something changed, we call, this one is off, yeah. We can call, oh, we need to make it mutable, of course. Rotary dot update. And that returns a result of a direction. So let's put it into a variable and unwrap this one and see what we end up with. So let's see the thing, go to definition, and that's enum. It says clockwise, counterclockwise, or none. Okay, we can work with that. So let's do a match on direction and then add in all the possibilities. Let's move that. Clockwise, let's create some integer, a mutable counter, and we call it, we initialize at 0, that's I32, something like that. And whenever it's clockwise, we're going to increase it. When it's counterclockwise, we're going to decrease it. And if it didn't move, nothing happened. Okay, getting there. We have some very rusty problem right now, and that is that we use the select on the, it's actually hard to see, it's actually hard to see the underlined arrow. Not sure why, but it says it's borrowing a moved value because we basically donated the pins to the rotary and we didn't really get them back because now the ownership is there. So we need to do something to get control back of the pins, or at least temporarily, and we can do that. So what we can do, if we look at the rotary, it has some methods, and one of them is pins, and that's returns a tuple of 2 of A and B, so that's the 2 type of pins. So that's perfect because then we get a mutable borrowed reference, and we just need it for a moment, right? So we can just do let. And we can even shadow the names, so we don't need to change the name. So now we have a mutable borrowed pin for each, and we borrow it just to do the select. The moment that the select fire, then this variable is out of scope again, so rotary can be used again, and then you can call the update. It's yeah, it's a little bit messy, but sometimes you gotta. Oh yeah, now we actually don't need to mute anymore. Fair enough. So yeah, let's this needs to be lined up. Let's print out something to say like count, so we see something happening. And we do need to do one more thing, and that's basically, it's a very embedded thing. We need to enable the interrupts. I'm not 100% sure what it really means, but we need to enable interrupts into Embassy that it will actually notice. If you don't, it will all compile and look fine, but it will end up just not doing anything. Let me check. Then you need to go Sorry about that. Let's go to the interrupt from the hardware. So that's in HAL interrupt, and there's a function we need to call enable, and you pass in interrupt and a interrupt type, HAL peripherals, I think, yeah, GPIO, and this needs to be, what does it say? Priority. I am not sure if it matters much. I'll put it on priority 1. Otherwise it will simply not do anything. Is this correct? Peripheral GP. No, it must be. Oh, right. It needs to be the interrupt thingy. Yeah. Okay, it needs to be unwrapped. Alright. Let's see what this does. So we're gonna. Oh, I need to connect it first. Disco time. Flash it. Well, at least it still works. And when we rotate, yeah, so I rotate this way, it gets higher. And I rotate back, it gets lower. So, this is pretty nice, I think. Especially because we had to do some plumbing, but for the rest, all the stuff is now neatly packed away in composable tasks. You can add them pretty easily. I think I will work on combining it with the network stack. That would be nice, that you can use this to, I don't know, adjust your heating or something like that. That will, you rotate, when you stop rotating, it will send the HTTP request somewhere. That kind of stuff is, I think, really useful. And yeah, there is some boilerplate here, but none of it is particularly nasty. So there's still all the stuff that I commented out. I will also be continuing on the PicoServe. A lot of stuff moved there. There's some new versions of Embassy have been released, and I think ESP Wi-Fi will be released to cargo soon. So I think that will clean up a whole lot of the Git references and everything. So I hope that will help, and I hope I will not take as long as last time. So yeah, thank you for watching. Please like and subscribe, as they say, and see you next time.